Hey everyone, in this lesson we will solve problem 3 on the collection of problems about higher order functions. So this problem 3 says, implement a function with the name of prod_events that given a list of integers, it returns a integer value that is the product of all even numbers within this list. So this problem is very similar to the previous one, where we had to multiply all elements in the list. However, here we only must multiply those that are even. The ones that are odd, then we do not multiply. So here we have two examples. Again, we have the same list that we used before. So we have, for instance, the application of prod_events in the list 2, 10, 5. So Haskell needs to check which of these numbers are even. So first we need to filter the numbers that are even. So in this sense, we only have 2 and 10. So now we multiply 2 and 10, we have 20, right? Then here we applied the function prod_events to the list 3, 1, 2, 4. So if we filter how many elements we have that are even, only 2 and 4 are even. So now we only multiply those. We have 2 multiplied with 4 is 8, right? So we basically need to multiply those that are even. So let's start the resolution of this problem 3. The first step is to open the terminal in the operating system. This is the same step if we are in Windows or Mac or Linux, okay? This is always the same thing, even the command to open the interpreter. So whether we are on Linux, Mac or Windows, we open the console. Now we go to a directory where we will store the Haskell solution file. Okay, so the code solution. So we have created a folder with the name of problem 3, and within this folder we will store this file. So if we see this folder is empty for now, so let's create the file. We will use the Kate editor. We just open Kate, and now we save this file as, for instance, the name. Well, it's important to just save it in here. So let's just name this as prod_events. Okay, here you can write the name that you wish. What's important is that you use the extension HS. So this symbolizes that this is a Haskell file, programming code file. So we just save this, right? So before starting implementing this function, what's important is that the first step that we need to do is give the type of this function. What is its type declaration header? So this type declaration is basically the name of the function and what is the input of this function and the output of this function. So this is something that this program statement already gives us. So the function name is prod_events, the input is a list of integers, and the output is a integer. So let's just copy this header into the Haskell file. So the name is prod_events. Let's just zoom this a little bit. We have as an input a list of integers, and as a output we have a integer, right? Like so. Now, to implement this functionality of multiplying only those elements that are even, let's just summarize a bit here the mechanism. The first step is that we need to filter the elements that are even. Once we have filtered this, then we multiply. We proceed to multiply those elements. So we need to first filter them. To do this, we will use a higher order function named filter. This is a predefined function in Haskell you can use anytime in the interpreter. Keep in mind that we are in the section on higher order functions problems. So indeed we will need to use here higher order function. So here we will use the filter. The function filter basically receives a function and a list of elements and returns the list of all elements within this list that the result of the applying of this function is true. So here, keep in mind, if we apply even to 2, this is true because 2 is a even number. So 2 is part of the output list. Then when we apply even to the number 1, we see that 1 is not a even number. It is an odd number. That's why we do not include this number into the list. Then 4, is it even? Yes. So we include this number into the list. Then 6, is it an even number? Yes, so the evaluation is true. So we include this element into the list. Finally, when we apply even to the element 7, this evaluation is false, so we do not include this number into the final list. So what's important is that the return value of the filter function returns a list of the same type as the input list, but with those elements that have been evaluated as true with this function. So what we will do to implement this is plot events. We will first filter all those elements that are even, and then we will multiply them. Okay, now to multiply them, we have already a function that does this for us, which is a function that we have implemented in the previous class. Now, the previous class is very important, okay, to solving this problem. So it is this function, the function prod, which receives a list of integers. It returns an integer, which is the result of multiplying all those elements. So prod, we just return the multiplication of all the elements inside this list. And to do this, we remember the higher order function fold L with the function of multiply. So we are folding from the left all those elements within the list, starting from the neutral element 1. So we just multiply 1 with all the elements in this list, and we go stacking, okay, on each multiplication. So this is a very important function, and we have explained in detail and deeply in the last lesson. So we have this function. So we have filtered all the elements. Yes, all the elements have been filtered, and then we can apply the product. So we can just make the function composition here, like so. Now remember that in Haskell, when we have a point between two functions, this means the composition operator. Imagine if I have a function f in mathematics or in calculus and a function g, right? So what about if I want to do something like this, f of g? Well, we can in Haskell do this with this notation. It is equivalent as doing this. So we first apply g to the element, and then we apply f within the result of applying g. Yes. So we first filter all the elements that are even, and then we make the product of all of them. Now, keep in mind that we are defining this function with implicit input notation. So now the argument of this function, which is the list of integers that we receive, is implicit. Now, keep in mind that this definition, okay, is equivalent as writing prod events given a list, for instance, L, then we apply the function product once we have applied the filter of the elements even inside this list L. So this definition and this definition are equivalent, and they are both correct. Now, in Haskell, it is always preferable to use the implicit notation for clarity and neatness. And in this course, we always provide the most efficient and elegant solution to the problems. So we will leave this solution, and we will comment the solution, okay, for the student. Remember that you can download this code in the downloadable resources of this lesson. So let's just now check if this is working right. We go to the console. Let's just open the Haskell interpreter with GHCI. Just press enter, and now we need to load this file so Haskell knows what prod events is, what prod is, and so on, right? So we need to load this file so all the functions are loaded into the interpreter. We do this with the directive load, and then the name of the file, which is prod events. So we just press enter, and as we see, the file has been compiled and the module has been loaded. No errors happen. If any errors have been happening, then the Haskell interpreter will have notified us. So let's just check this function behavior with the examples given. So let's just apply first the function prod events with the list 2, 10, and 5. So we use the function prod events with the list 2, 10, and 5. So this shall return 20. And as we see, this is true. Then again, when we're trying to use this function with the list 3, 1, 2, 4, this shall return 8. So we again apply this function with the list 3, 1, 2, 4. We press enter, and as we see, this gives us 8. So as we see, this is working right, and you can try with any list that you may occur. Have, for instance, 9, 3, 6, 5, and 2. This shall be 12, which is basically the multiplication of 6 and 2. The rest are odd numbers, and we see that this is true. So as we see, this function works right. We remember that you can all see and download all this code, okay, even the code that we've been writing on the previous problem, which is the function prod. Okay, you can download all this code file in the downloadable resources for this lesson, as well as the slides used in this class.